In this video, we are going to discuss how to calculate the center of mass of a system of particles. The question says, the Earth has a mass of 5.97 times 10 to the power 24 kilogram, and the Moon has a mass of 7.36 times 10 to the power 22 kilogram. The Moon orbits the Earth at a distance of 384,000 kilometers. That is, the center of the Moon is a distance of 384,000 kilometers from the center of the Earth. Problem is asking us, how far from the center of the Earth is the center of mass of the Earth-Moon system? Let us first sketch our problem. We have the Earth. We'll call this Earth. And the Moon. The distance between the center of the Earth and the center of the Moon is 384,000 kilometers. And we need to find where does the center of mass for the Earth-Moon system lies. Now the rule for the center of mass goes like this. XCM equals x1 m1 plus x2 m2 over m1 plus m2. So since we are considering the Earth-Moon system along the x-axis, I'm going to take the coordinate of center of mass along the x-axis, where x1 is the position of object 1. In this situation, object 1 we are considering as Earth, and it has a mass of m1. x2 is the position of object 2, which is Moon, and it has a mass m2. The question has given me the distance between the center of Earth and the center of Moon. It has not given me their position. In such situation, we consider the position of the first particle or the first object to be at 0. We take the position of Earth as the reference point. So I will consider this position to be equal to 0. So we can take x1 to be 0. I can consider Earth as my reference point. And the position of Moon from the Earth x2 will be 384,000 kilometers. Now we can calculate the position of center of mass. I will just substitute the values here. Since x1 is 0, I can remove this whole term and write the equation as x2 m2 over m1 plus m2. Now substitute the value of x2, m2, m1 plus m2. We get x2 is position of the Moon, which is 384,000 kilometers, times mass of the Moon, which is 7.36 times 10 to the power 22 kilogram, divided by mass of the Earth, which is 5.97 times 10 to the power 24, plus mass of the Moon, again 7.36 times 10 to the power 22 kilogram. And when you solve this, you get your answer as 4676.418 kilometer. So the position of the center of mass is 4676.418 kilometer from the center of the Earth. And since all of our values are in 3 significant figures, we can round this off to 3 significant figures, which will become 4680 kilometer. So this is my final answer for the position of center of mass of the Earth-Moon system. Whenever in the question they give you distance between two objects and not their position, you can assume the first object to be at a position of x equals 0, and the second object will be at a position of the distance given between them. And then you can use the rule for center of mass. Now let's go to the next question. The question says, coordinates of the center of mass for extended object shown in the figure are L by 4 and negative L by 5. What are the coordinates of the 2 kilogram mass? Now in this question, they have given us the coordinate of the center of mass, which is L by 4 and negative L by 5. We need to find what is the coordinate of the 2 kilogram mass. The 2 kilogram mass is the blue ball over here. And I need to find what are the coordinates of this mass. So I'm going to consider this as my object 1. This will be object 2. And let this be object 3. I have the position of center of mass for these 3 objects combined together. I need to find what are the coordinates of object 1. So let us first write down what is given to us. We have the position of center of mass. I will call it R, which will be XCM and YCM, and that is L by 4 and negative L by 5. Then we have object 1. Position of object 1 will be x1, y1, which we need to find, and we call them to be x comma y. That is given to you in the figure. And object 1 has a mass m1 of 2 kilogram. Then we have position of object 2, r2, which is x2, y2. And I will write this as L comma 0. And mass is 3 kilogram. We write the same thing for object 3. Its position will be x3, y3. And the values are 0, negative L by 2. Mass of object 3 is 4 kilogram. I need to find the values of x and y. So let us start with the x coordinate of the center of mass. We know the rule for the x coordinate. XCM will be x1 m1 plus x2 m2 plus x3 m3 divided by m1 plus m2 plus m3. So whenever you have a system of particle and you need to find the position of center of mass, you multiply position of each object with their masses, add them all together, divided by the total mass. Let's substitute. XCM is L by 4 equals x1 is x, which is something that I need to find. M1 is 2 plus x2 is L, L2 is 3, M2 is 3 plus x3 is 0 and M3 is 4 divided by 2 plus 3 plus 4. Now when you solve this, you get L by 4 equals 2x plus 3L divided by 9. I need to solve this to find what is x. So first thing I'm going to do is multiply both terms by 9 because I need to get rid of this 9 in the denominator to solve for x. When you multiply both sides by 9, you get 9L by 4 equals 2x plus 3L. Now I'm going to move this 3L to the other side to leave 2x alone. And when you do that, since this is positive here, when I move it to the other side, it becomes negative. We get 9L by 4 minus 3L equals 2x. 9L by 4 minus 3L will give me negative 3L by 4 equals 2x. And when I solve for this, I get x equals negative 3L by 8. You divide by 2 on both sides, and that gives you x equals negative 3L by 8. Now we do the same thing to solve for y. For y, we write yc equals y1 m1 plus y2 m2 plus y3 m3 divided by m1 plus m2 plus m3. Now do the same thing. YCM is negative L by 5 equals y1 is y, which is what we need to calculate, times 2 plus y2 is 0 times 3 plus y3 is negative L by 2 times 4. divide by 2 plus 3 plus 4. Now this total mass, either you can calculate in the beginning and just substitute, or you can solve the way I have solved it here also. Now let's rewrite this expression. We get negative L by 5 equals 2y minus 2L divided by 9. Again, I will multiply by 9 on both sides to get rid of this 9 in the denominator. So negative 9L by 5 equals 2y minus 2L. Move 2L to the other side. Since it is negative here, when I move it to the other side, it becomes positive. So we get negative 9L by 5 plus 2L equals 2y. When you solve this, negative 9L by 5 plus 2L, that gives you L over 5 equals 2y. Divide by 2 and you will get y to be equal to L by 10. So this is the y coordinate. When you write the two coordinates together, position of mass 1 or position of object 1, R1 to be equal to x value, which was negative 3L by 8, and y, which is L by 10. This is your final answer.